put your hands together for Reactor Grow!
Thank you, Amol, and thanks everyone for coming. I don't know how we're going to follow the award up, but we'll try our best anyway. As you said, we are Reactor Grow. We are Pavel, Mikhail, Emily, and Laurent, and I'm Jacob. The basic concept behind our idea is an automated greenhouse environment. Now, we thought this would be coming useful for those who like to travel, but also want to monitor their plants while they're away. We were very keen to use hardware immediately, and after much research, we looked at either the Raspberry Pi or the Arduino. Now, we went with the Raspberry Pi because we knew it would have better processing power, and also it has more features for us to use. Now, I'm going to pass you on to Pavel, who will give us a demonstration of the device.
Thank you, Jacob. Hi, everyone. So the device is Raspberry Pi 3B+. We have an outside temperature sensor, inside temperature sensor with the humidity sensor. This is the soil moisture sensor, water pump, and it's going through the analog to digital converter because the Raspberry Pi only takes the digital inputs, which we didn't know before. But anyway, let me show you the video, how it runs. So it takes the reading, the Python script. Because the soil is dry, it's pumping the water for 3 seconds. Next reading, the soil is moisture enough. I'm holding my hands so the inside temperature can go up, and it will trigger the top window to open to release the temperature. And the script is going into intervals. Every, I think, 5 seconds, the window is open, release the heat. Once it's cooled down, it will close back again. So I'll pass you on to Laurie, who will explain the front end.
Thank you, Pavel. Hi, everyone. So in order to give you the best possible features, we decided to develop a website and a mobile app as well. So here you can see our mobile app with our beautiful logo. Oh, that was a bit fast. So here you can see all the data related to the greenhouse. And you can also see the soil moisture which is related to the plant. You can set the window to open or close. You can set the pump. And then you can go to the other screen where you can see all the available plants. Yeah, this is our beautiful navigation. You can go back there, and then you can just log out, and it shows that you are logged out. Now we can go onto our website. Here's the login screen. Just a few seconds. Then you can see a beautiful quotation which is related to the automation. There you can see your greenhouses. We will choose the first one, which will take you to the greenhouse where you can see all the related data. And you can see the chart. There's a 7-day chart where you can see the historical data, and there's also a 24-hour chart. And then if we scroll down, soon, then we'll see the current plant, and we'll see the same, the historical data for 7 days, and we can see the 24-hour chart as well. And then we log out. And now I'm going to talk you through about our tech stack. So on the front end, we used React.js. For the website, we wanted to use something that we were comfortable with. We knew that it would be really easy and really fast to develop a website. For the website, we used Bootstrap. Due to the time constraint, it was just easier to build something which is really nice and easy to show. For the mobile app, we chose React Native simply because we wanted to use a new technology, and even though it's new, the syntax is quite close to React.js, so it was quite an easy decision, I guess. For the charts we used on the React.js side, we chose Chart.js over Google Charts. The decision was made by the group simply because some of us used Google Charts before, so we wanted to use something new. When you choose React Native, you have two options. You can go for the Expo or you can go for the vanilla React Native. The decision that we made why Expo is a better fit for us because that provides you a complete package, gives you really easy development right from the beginning, right from the get-go. You can just download an app from App Store or from Google Play Store, and then you can scan a barcode and you can see the development right on your mobile phone. Over that, it allows you cross-platform development, so it's also a pretty cool feature. And I think that's it. I will give the microphone to Michael, who will talk you through the backend.
Hello, everyone. I'll go now through the technologies we use on the hardware and the backend. First, I will mention, as you can see, it might look scary, a lot of cables, and it was a big project, and I'm really proud we achieved it. It basically goes with hardware, 2 front ends, and backend. So as you can see, there's a lot of new technologies. So for the hardware, we run it on the Raspberry Pi. It runs on the Raspbian operation system. And the language we used is Python. We, from the very beginning, wanted to go with new language. We wanted to learn some new technologies. And for the hardware, we could choose between Java, C++, and Python. Why Python? There are more libraries for Python. As you can see, a lot of going on with the project, so we've got very narrow time to finish everything. And Python fits very well with whole project. So the Python is working with library Adafruit. Adafruit library takes all the readings from the sensors and sends the signals to the receivers. And that's it for the hardware. So hardware sends all the data, collects every data, and sends it to the backend as a JSON string. So if it's about the backend technology, we stick with the Python. Makes good synergy with the hardware. As you can see, there's a Flask. For those on the backend, the Flask basically is the same as Express. We use SQLAlchemy. It's like abstract layer between the language and the database. For the database, we went with PostgreSQL. SQL database fits very well with our data. And we've learned PostgreSQL on the course, so as well, we got very narrow time, so we stick with the Postgres. And the backend is hosted on Heroku. At the beginning, we wanted to go with AWS, but as you see, a lot of is going on. We have to decide with what technology we will stick, what we will be able to achieve. And that's it for the technologies we've used. Now I'll pass microphone to Emily. She'll tell about the challenges. Thank you.
So thanks, Michał. So what I'm going to do is I'm going to talk to you a little bit about the issues and the problems that we faced when we were making our project. So no team doesn't have issues. If they say that they don't have issues, they're lying. We had a couple. I'm just going to go through them for you. So the first one was hardware. So we knew really quickly that we wanted to use a Raspberry Pi. So we got that ordered. We got everything sorted out pretty quickly, and then when it arrived, we realised that one of our components needed an analog to digital converter. It only took on, the component only ever took on an analog signal. The Raspberry Pi only takes on a digital signal. We needed a converter to do that. So we ordered that from pretty well-known, I'd say, online shop with 24-hour delivery. Other options are available, I do have to tell you that. So that we waited for that. They said next day delivery before sort of 9 p.m. We thought, great, it's going to be here before sort of midday. We'll get everything sorted. Well, 5 o'clock came and went. It still wasn't there. And we said, well, it's probably going to come tomorrow. It arrived that night at about 9:30. So instead of wasting that day, we spent that day kind of researching the component that we'd bought, researching what we needed, how it was going to work. So when it arrived, we were able to just get everything sorted, get everything fixed. Midday the next day, everything was set up. We didn't waste any time that way. The next problem we had was hosting. Like it's been mentioned, we wanted to host our app on the App Store, on Google Play, so we started researching that. But obviously this project, there is a massive time constraint, and it wasn't going to be possible. So we decided instead to use Expo, which is what we created the app with. There is a version called Expo Client. Again, we did try to host it on there. And again, we had problems with that. So what we've done is we've set it up with a QR code. So if the user wants to, for instance, have their friends look at their plan to see how it's working. They can send the QR code to their friends can scan the QR code, and they can have a view on the app themselves, which is great as well. It's quite social, you can share it on your social media. I think that's a really cool idea. And the third issue that we had was React Native. We'd used React.js quite a bit in our presentation. In our while we were working on with North Coders, and we kind of thought, we'll try React Native. It can't be quite so different. It is a bit different. The error messages are nowhere near as forgiving. React.js, it holds your hand, it tells you what line the issues are on. React Native doesn't do that. And we did spend lots of time thinking, this is new. And then after we did that, we thought, well, you know what, let's do some research instead. Instead of sitting there and, I don't know, not doing something about it, we decided, let's be proactive. Let's do some research. Let's figure it out. And as time went on, we figured out the issues really quickly. We solved everything really quickly. There were no problems there. And again, I'm really proud of what we've done. I'm really proud of the team. It's been such a good, everyone's put in a really good effort. I'm super proud of them. So I just want to say, if anybody wants to have a look at this or have a bit of a play around with it afterwards, you're more than welcome to do so, although please do wait until the other team have finished their presentation and answer their questions. That would be really, really nice of you. So that was us. We were Team Reactor. Thank you very much for your patience and for your attention. If you have any questions, now's the time.